I'm going to walk through some of the LMDM software components that make up the One Spatial platform. These will include our portals and dashboards from One Data Gateway, business apps that use our One Integrated Rules engine, machine learning, our LMAP SDK, and what the future may also look like with augmented reality. This is One Data Gateway, which is our portal that helps us administer all our business apps and deliver them to the right people. This is where we set up our accounts for users, and then once you have your account, you can manage your profile and how you want to be seen. You can also set up supplier or organizational groups to make it easier to control access to your business apps. It's a simple case of quickly adding users as members of your group, and then you can also manage the look and feel of the group itself through simple avatars. The portal also provides you with the usual system-level operations. These are things you expect from a portal, like configuring email notifications, and even integrating with external identity management systems like Microsoft Active Directory, Google, or ArcGIS Online. Each Focus Business app is controlled by a project. This is where you can manage the look and feel of the app to brand it exactly how you want. Each project is then controlled by a specification. You can control how long the data is retained, whether the app is active, and how flexible you want it to be when people submit data. You can control what people upload and download, or even hide data sources that are for the app to worry about and not the user. You can also control who has access to the app, either by individual users or by the groups of users that we looked at earlier as suppliers. And if there's extra information that you want to provide via the app, you can also control that here. These become the apps you deliver to your customers. We also have dashboards so we can see and track how projects and organizations are doing, including uploads over time. And as the administrator, you can also drill down into individual app performance if you want to look at specific projects and specifications to check out data quality trends, rules that have got the most issues, and even export those out for your own reports. As a simple user who just needs to use these apps that you've created and made available, all you're really going to do is see two things when you log into the portal. The two things that we'll be focusing on would be your assignments and your submissions. Your assignments are the specific set of apps that you've purchased or been given access to. It's a simple case of just selecting the app you need and then kicking off your submission, where you upload your data and away you go. For each app, you can always go back and look at your past submissions, and you can even check out what happened in the past. You can also see a simple dashboard that relates to you and your submissions that you've made in that app. And because you're likely to make in use of multiple apps, you can also view all of your submissions again and drill down just as before to see where you're up to or check back in your history if you need to. Let's now check out some use cases and see how the business apps that we've developed are used in the real world. I've got some transport and utility data to play with, and I'll pick up some apps that work with all the different aspects of our platform, from validating data right through to data improvement. This is the Ecology Survey app, and all I need to do is start my submission and upload my data. Major development projects often need to undertake detailed environmental impact assessments as part of the planning process, and this incorporates ecological impact assessments of how the development will affect biodiversity and habitats. This typically involves multiple contractors submitting data from surveys in different formats that can be difficult to verify and analyse. So this app allows suppliers to validate data prior to submission. Once you upload your data, the app checks to make sure the data you've provided conforms to the right schema. It then checks all the data against all the rules defined in the spec and gives you a summary of those results. You could choose to preview your results in a map, or if you're happy with the summary, you can continue to get the final results. At this stage, you can download an audit log of what happened, grab a quick summary report of the results as a PDF for your records, or if you're happy with all that, you can very quickly download the complete output and complete your submission. It's that simple to find out if your data is valid, download information about any issues so you can fix them, then quickly rerun the process to confirm it's all checked, and then you're confident that the data is valid before you push it along your supply chain. As with all the apps, you can very quickly go back and check your past submissions and also have a quick look at any dashboards if you want to see how things have been progressing. Ensuring the right environmental impact assessments are completed allows works to be carried out. Now let's look at how we might identify where works might take place. The next biz app I want to focus on is leakage, which is a real challenge for utilities. The Leakage app follows the same simple data submission process as all apps. I first let the app know where my source data is. Once that is uploaded, the app will check that it conforms to the data model that it needs. I could review the mapping if I needed, but for now I'll just continue. Once the data model is validated, the data processing takes over. Here our 1-to-8 rules engine loads and processes the pipe network data before feeding it through a TensorFlow model to give each pipe a burst prediction. Our approach to helping solve the data problem around leakage is using both our rules-based approach and machine learning. The rules-based approach is used to cleanse and normalize the data, populate missing values, resolve the noise in the data, and prepare it for the machine learning step. We've created a machine learning model for leakage prediction using Keras, which is a deep learning API written in Python that runs on top of the machine learning platform TensorFlow. We trained the model on all sorts of data, from transport networks to elevation models, and you can find out more about this during the Utilities Day. Before downloading the results and completing the submission, I'm going to quickly view the results in the map just to confirm that everything is as I expected. Once I'm happy with this, I can then move on to the next step and finally download the output and complete my submission. So the new data is what I can then use to help identify and prioritise a list of high-risk leakage areas, effectively a heat map that will direct the most effective resources more efficiently, prioritise the finding and fixing of where the areas are that I think are impacted by the biggest leaks. Now let's focus on a different problem for many customers, and that's making sure that the positional accuracy of all your data is fit for purpose. Let's take a look at a simple example where we can see there is a misalignment between the base map and the network. This is where our PAI app comes in. Just like the other apps, the PAI app starts with a simple data submission. Once my data is loaded and checked for consistencies, it's straight onto the processing step. In this specification, I've supplied both the source network and some shift vectors, which I captured in the field to show me where the old position was and where the new position really is. Our powerful transformation algorithms in OneIntegrate then use the shift vectors to adjust the position of the data automatically. If you didn't have shift vectors, there's other specifications that use before and after base maps to generate them for you. The shift's been applied and I'm just doing a quick visual check to make sure I'm happy before I finally complete the submission and download the results. Back in my GIS, I can see as I switch between base maps, the misalignment is clear and obvious. Here I can quickly show the shift vectors that were generated out in the field that were then passed into the transformation process. And then I can bring in the new positionally improved data that was downloaded to see how the alignment has worked out. Just to double check, I can just now flip between the imagery, the OpenStreetMap base map, and even some OS Open raster base map, just to make sure the data is now in the correct position. Now let's take a quick look at another interesting area in our network. Here we're going to look at a business app we've created, not as part of a portal, but as a mobile application that takes the same rules-based processing out into the field. This is a business app we created using our LMAP SDK. I'm just logging into it on my Android tablet, and my first step is to create a job so I can download some data and head offline and out into the field. Once the job is open, I can quickly begin and search for the feature or area of interest that I need. Using the different base maps, I can quickly see that this data needs to be positionally improved as well as replaced with a new piece of network. First, I'll use the existing network to act as a guide to help me create the new feature. The app has rules to help me snap to existing features so I can make sure the edits I do are captured right first time. If I make a mistake, I can quickly undo a few of the edits and then carry on. As well as having rules to make sure the spatial elements of the network are accurate, rules also help to check that all the attributes are correct as well. Again, capturing everything accurately first time. Now I've captured the replacement pipe, I can quickly remove the old one. The app allows me to follow a similar process for all my data capture needs out in the field. It provides the same secure spatial and attribute checks that I need, online or offline, so that everything I do is right first time. This means I'm going to reduce the need for quality control tasks back at the office and help maximise the value of each visit I do when I'm out in the field. Once I've completed my job, I can close it, the job is synced back to the office, and I can log out and move on to the next job. The final business app, whilst we are looking at getting transport and utility companies ready for carrying out works, is focused on traffic management plans. This is a targeted app looking at producing traffic management plans that implement the right rules on signing, lighting and guarding arrangements at roadwork sites, and it looks to present those plans in a fast and simple way for users. Let's see how it works. It's a simple web application that allows me to position where on the road network I'm planning my works. It then takes as much information from the network as it can to support the planning process. Let's give this plan a name. If there's any additional information needed, a workflow guides the user to provide that information if they have it. Additional information could be things like traffic counts, or whether there are cycle or bus lanes that need to be considered when creating the plan. Once all this has been submitted, I can use the web app to draw up where the excavation is planned before I finally confirm the details and then kick off the processing to generate the plan. Final confirmation will be needed just to make sure that multiple excavations aren't needed, and then the processing will begin. At the processing stage, all the data is being analysed and processed in accordance with the signage, lighting and guarding rules so that a proposed traffic management plan can be generated. The rules are using the information provided by the user and many other external data sources to build the plan. The process takes around 1 minute. The alternative manual method is a very long process. It's got a long production time and high production costs, especially if there are multiple amendments needed to make and correct mistakes. The process can be lengthy, often taking over a week to produce a traffic management plan that is fit for purpose. And here it is. All the signage and equipment that is needed, based on the type of roadworks planned, and most importantly its location. Together, that means that the correct signage, lighting and guarding arrangements can be made and predicted to keep everyone safe if the proposed works is granted and gets underway. If I'm happy with the results, I can quickly export a PDF version of the plan for my records. And as well as the map view of the planned works, we can use the data created to create an equipment list of everything that is part of the proposed plan. This gives us a great inventory to use in our planning, and it also lists all the supporting information that was used to generate the plan. We've done all the hard work in the TMPA solution to generate high accurate data following the rules-based approach. Now we're looking at other innovative ways to unlock this data's potential. And here's one where we're even taking that same data but using it in a simple augmented reality app, so we can start to see what the proposed signing, lighting and guarding arrangements might look like in a virtual world. So that was a quick overview of some of our LMDM software components that make up the One Spatial platform, from portals and dashboards to rules engine and machine learning, SDKs, and what the future may look like with augmented reality. You'll be able to find out more about all of these in more detail over the next 3 days.